Alright, now that we've gotten our basic definitions of the right triangle trig ratios for acute angle theta, let's take a look at how we can use these to solve for sides and even angles of right triangles. Now, feel free to pause this video and copy this procedure into your notes. And refer to this procedure as you are getting comfortable with some problems. I will work these three examples out. So the first step is to assign sides relative to the acute angle you're going to use as opposite, adjacent, and hypotenuse. So I am going to use acute angle 36 degrees. That's going to make 17 the hypotenuse, which is across from the right angle. W here will be adjacent, because it is right next to 36 degrees, and R will be opposite. So step one is literally just right on the picture itself. Hypotenuse, adjacent, opposite, but relative to the acute angle that you are going to use. I'm using 36. Okay. Next, we're going to determine which definition, which trig function to use, and we're going to write that definition down. So if I want to solve for R is the opposite side, and I know the hypotenuse. Sine is the trigonometry function that uses opposite and hypotenuse. So we'll write down that definition. Sine theta equals opposite over hypotenuse, and that is step two. For step three, we are going to recopy this definition, substituting the values from the problem. There are three values here, theta and two side lengths. Two of them are going to be known from the problem, and one is going to be an unknown variable. So the acute angle I'm using is 36 degrees. The opposite side is lowercase r, and the hypotenuse is 17. So that is step three. Substitute in the two numbers and the one variable from the problem, and then simplify. Now, because there are three different numbers, there are three different versions of how to simplify these. The first case is when the variable is in the numerator and you know the angle and you know the denominator. And in that case, we are going to just multiply both sides by the denominator to get the variable all by itself. This is how you would write, by the way, some number multiplied by the trigonometry function of some angle. The number in front is the coefficient. Then the trig function, and then the number after is always the angle. Now, 17 sine 36. Now we take our calculator out. We need to make sure, actually, that we are in degree mode. And depending on your calculator, you may have to change things around a little bit. But if we're using degrees, we need to be in degree mode. You will learn about radian, angle measures in pre-calculus or some other course. So for freshman geometry, everything's in degrees, so make sure your calculator is in degree mode. The only time that matters, by the way, is when you use these three buttons. So most calculators, you type it in exactly as I have it written here. And to one decimal place of accuracy, let's call that 10.0. So R equals 10.0, and we use centimeters here for our units.